Okay, so today we're going to take a look at the Arturia MiniBrute2S. This is a synthesizer I own. It's an analog 2-oscillator synthesizer of medium complexity, not too simple, not too complicated. One of the nice features about this, though, is it's considered semi-modular in that you can use it with a modular rig by using modular level patch cords to other equipment. So let's take a quick look at it. This image here is the hero view, if you will, just showing you the synthesizer. And there are actually two versions of the revised version of the MiniBrute. Arturia came out with the MiniBrute 2, and that's a keyboard version in which there's a 25-note keyboard that's very similar to the one found on the Matrix Brute. And there is above that a simple sequencer, and then above that is the synthesizer section. On the MiniBrute2S, we skip the keyboard for 16 velocity and pressure sensitive pads, 16 encoders, and a much more full-featured sequencer system. We're going to ignore the sequencer in this video and just talk about the synthesizer section at the top of the unit. And the synthesizer section of the MiniBrute2S and the MiniBrute 2 are identical. So up in the upper left corner is the LFO section. And you can see here there are two LFOs, numbered 1 and 2. Either LFO or both can be synced to tempo. So if you put it in the sequence position, it will sync to the sequencer's tempo setting. Or in the free position, the rate knob will just simply choose the number of hertz of the cyclic effect of the LFO. In the sequence position, you can choose it to be whole note, half note, quarter note, eighth note triplet, you name it. Now, both of them have identical capabilities, and the wave knob chooses the shape of the LFO's modulation. So at the top, we have the sine wave, we have a triangle wave, we have a ramp downward, we have a square wave with a 50% duty cycle, and then we have two random waves. We have a stepped random, which is essentially a random value that is held until the next random value, or we have a smooth random in which the random value kind of glides between values in a smooth way. So that's the LFO section. Next to that, we have our oscillator section, and we have two oscillators, as I mentioned, plus an oscillator mixer. Let's take a look at the oscillator mixer first. And we see something very similar to what we saw in the Matrix Brute. We have, in this case, sliders to control the sawtooth level, the square or rectangle wave level, and the triangle wave level. There's also a slider for white noise. There's a slider for an external input. And then there's the slider for oscillator 2. Now, looking at the top row at VCO1, we see, first of all, outlined in white, the fine-tune control. And this has a fairly wide range, about 2 octaves, an octave up and down. We have next to that a glide control, so we can get a little portamento effect between notes if we turn that up. And then we have a pulse width control that affects the rectangular wave. So at minimum, it is a square wave, and as you bring it up, you'll get a narrower and narrower pulse wave. We have a metallizer effect on the triangle wave, which is a kind of wave folder effect. And on the sawtooth wave, we actually have an ultra saw effect in the second row. Now, in the second row, these are modulators. There is a frequency modulation, and the normal source for that is VCO2. So essentially, the output of VCO2 is going to raise and lower the pitch of oscillator 1, which can produce some pretty interesting metallic, weird sound effects or some pretty complex waves. So the FM mount adjusts that. As I mentioned, we have an ultrasaw mount, and that is normally controlled by LFO2 and that rate and that wave shape. We have a pulse width modulation control. So you set a fixed setting with a pulse width, but with the PWM knob, you can bring in LFO1, and now that will bring the position of the pulse width up and down at the rate specified by LFO1. Finally, we have a metal mod. So this will affect the amount of metalizer, and that's normally controlled by the keyboard's velocity setting. On oscillator 2, we have a tune control as well. There is a range switch, and in the fine mode, we have the normal kind of multi-octave range, but in the all mode, we can really run the gamut of different frequencies, from extremely low to extremely high. And in the LFO mode, VCO2 becomes very, very slow, very low frequency, so you can treat it like an LFO and use it as a third modulation source for VCO1. VCO2 has 3 waveforms, so it has a sine wave, which is excellent for giving a little bit of reinforcement to the sawtooth triangle and square waves over an VCO1. We also have a sawtooth wave, and we have a 50% duty cycle square wave. And again, as I mentioned, the oscillator 2 slider below it is what brings that into the mix. Going to the next section, we have really 4 things going on here. We have a filter section on the left, on the top, and below it we have the ADSR envelope that is normaled to the filter section. On the right, we have the amplifier section, and below that is the AD envelope that controls the amplifier section. Now, breaking into the filter a little bit more, we see outlined in orange the cutoff knob. This is a standard thing on a filter. This happens to be a 2-pole or 12 dB per octave filter. And it uses Niall Steiner's design, which allows you to have different kinds of filter capabilities. It's a multi-mode filter, if you will. We have resonance next to the cutoff, pretty standard stuff. And then we have the mode switch. And the switches between low pass, when this is at the top. We have a band pass mode. We have a high pass mode. And then we have a notch filter mode as well. Now, the FM knob that's beneath the orange cutoff knob is going to send the ADSR envelope below that to the filter. Now, when that FM knob is at 12 o'clock, in other words, pointing straight up, it has no effect on the filter. As you turn it clockwise, so here it's at 4 o'clock, you're going to get a lot more effect of the ADSR on the filter. So instead of the filter just going wah, it's going to go wow, depending on your ADSR settings. If you turn the FM knob the other way, then the filter will actually be pulled down by the ADSR. So the ADSR will work in the reverse direction, which can be a pretty cool effect as well. And also when you're dealing with things like the high pass mode, having the ability to invert the filter is very useful. Now we have a resonance control, and below that we have resonance modulation, or RM. And normally that is also fed by LFO1. So you can just crank that up and add more to the resonance, or you can turn it in the other direction and bring the resonance down and up with the LFO. With an LFO, it's not going to make much difference, but if you plug something else in as the source, having the ability to go in either direction could be very useful. Finally, we have the attenuator 1 control. And this is normal to the cutoff, and it's normally fed by the pressure or aftertouch from the keyboard. So if you crank this up, holding down a key and pressing harder will make the filter increase in level. So if you have a low-pass filter, you'll get a sudden brightness when you press harder. Now you can plug other things into Attenuator 1, which we'll get to when we look at the patch bay, but that's what that's for. Now the knob that's outlined in blue is called Brute Factor, and it's included in the amp section, but it really is interacting with the filter section. And what's happening here is that the filter's output is going through the Brute Factor and then being fed back into the input of the filter. And what this does in small amounts creates a nice, big, warmer, fatter sound. And as you increase it, it can really make things beefy and crunchy. And increase it even more, you can make the filter very unstable and chaotic. It is an analog device, so it will, when pushed to its limits, do chaotic things. And that's a really interesting area to explore in this synth. This is something also from the MiniBrute and the MatrixBrute and the PolyBrute. This is a thing that Arturia is very big on. And it's not a novel idea to them. Other synths have used this as well. But it does add some really interesting layers of sound when used in moderation or with extremes. Of course, we have a master volume framed in white ring to the upper right. And below that, we have Attenuator 2. And this normally feeds the amplifier. Now, the interesting thing about Attenuator 2 is it has a steady 5-volt signal as its input. So as you bring up the Attenuator 2 knob, you're raising the amplifier and opening it up. And that means we'll hear sound. If we have any of the oscillators on at the oscillator mixer, we'll hear them. In other words, we don't need to trigger the notes from the envelopes. They'll just play continuously, and this can be great for doing drone music. You can also plug a different signal into Attenuator 2, and then in that case, it's just simply controlling the amount of that signal affecting the amp. And of course, to the left of that is Global Tune, and this will affect both oscillators at the same time. So it's a way to make your instrument tune with other instruments. Below the amp section, we have the AD envelope. Now, this is a simple envelope with attack and decay. Now, there's a gate trigger switch. When the gate is on, we have an A gate R envelope. In other words, we have a variable attack time, and then we will stay at maximum level while the gate is being held. In other words, as long as you're holding a key. And the moment you let go of the key, will begin the decay cycle. If you have it in trigger mode, though, and you press the key, it'll immediately start to attack. And when it reaches the end of the attack time, based on the attack slider, it'll immediately start doing the decay time, based on the decay slider. So you don't sustain those notes. You just simply go up and down. Now, in addition to that, there's another switch at the bottom that's called the once or loop switch. So in the once mode, pressing a key will cause one envelope to occur. It'll function like a typical one-shot envelope. But if you put it in loop mode, as soon as the decay cycle ends, it'll begin the attack cycle again. So that will just continuously make envelopes all the time, and it becomes a kind of LFO, a cyclic effect, when it's in loop mode. And ADSR, pretty self-explanatory. We have control over attack, decay, and release time, and we have control over sustain level. Works just as like you expected it would. Both of the two envelopes have red LEDs that get brighter and darker as the envelope rises and falls. So fun stuff there. One more thing about the AD envelope that we'll see as we look at the next slide is that the envelope attack and decay times can be controlled externally by another source. So let's take a look at this patch bay, and this is really interesting. This is what makes the synths semi-modular synthesizers because they can be hooked up to other modular synthesizer equipment. It's 100% compatible with Eurorack. In fact, Arturia makes something called a MiniBrute2S that is fully Eurorack compatible, so you can integrate your Eurorack system with this synth. Now, looking at the different sections, it's all laid out pretty well. We have VCO1 at the top left, we have VCO2 to the right, and an external input section. In the second row, we have a filter section, amplifier section, and something called an inverter, which will just simply make high voltages low and low voltages high. Then we have our two envelopes. We have the ADSR section and the AD section. We have LFOs 1 and 2. And then in the bottom left, we have something called a VCA. Now, this VCA is a little interesting in that normally the amount of VCA is going to sit at a high level because we have the 5-volt signal feeding the control voltage input. So if you don't plug anything into the control voltage input, the VCA is at maximum level. It does have 2 inputs, though, so you can use this as a very simple mixer. And then we have the output below input 2. If you plug something like an LFO or an envelope generator into the CV, then now those signals coming into inputs 1 and 2 can be controlled by some third signal. Next to that are our 2 attenuators, and as we mentioned, attenuator 1 normally feeds the filter. It's normally fed by the pressure from the keyboard, but you can plug something else as the source on the input, and then below that we have output 1, which goes to the cutoff. Attenuator 2 is normally fed by that steady high voltage of 5 volts, but you can plug something else in, and the output of attenuator 2 goes to the amp. To the right of that, we have the sequencer. So we have the ability to have a clock input, so we can synchronize the sequencer on the MiniBrute2S to an external clock. We also have a reset command that can, a pulse, a trigger can go into the reset. Below that, we have 2 outputs, and if I didn't make this explicitly clear, everywhere where you see text in a white box under a jack, that is an output. Everywhere else, it is an input. So we have 2 outputs from the sequencer. We have a sync output, and we can use that to synchronize another Arturia MiniBrute2S or other compatible sequencer. And we also have a run output. So this is just simply a trigger that whenever we hit the run button on the sequencer, a pulse will go out to run an external sequencer. Next to that, we have the MIDI output. Now, the MIDI output comes from the keypads on the MiniBrute2S, or in the case of the MiniBrute2, from the keyboard, but also from the sequencer. So the keyboard output is a pitch output that determines the different notes that you're playing on your sequence. We have a gate signal, which is which every time there's a note that plays, we'll have a trigger coming out of there. We also have 2 tracks on our sequencer, mod 1 and mod 2, and these correspond on the keyboard with the velocity from the keyboard and the pressure or aftertouch of the keyboard. So you have those outputs there. Now, if we look at, say, the filter, we see that the filter in row 2 here gets its signal from ADSR, and that feeds the FM control. And as you'll recall, we looked at the FM control and saw that ADSR, in fact, is the source there. So that's just confirming on the patch bay that that's the normal input to the FM control. But you can plug something else like an LFO into the FM control. Next to that, we have the resonance modulation. So we have frequency modulation of cutoff and resonance modulation, and that is normally fed by LFO1. And then we have attenuator 1, which normally feeds the cutoff. So if you look at the two attenuators in the bottom row and you look at attenuator 1, it says out 1 to cutoff. And then in the filter in the second row, we see that attenuator 1 is in fact the signal that goes to cutoff. Next to that, we have the amplifier, and we have the AD envelope feeding the AM. We don't have a control for AM. It's just normal to do that. But if you wanted to do maybe some sort of weird amplitude modulation, say with an LFO for tremolo effect, you could maybe do that. Probably a better way to do that would be, though, to plug the LFO into attenuator 2. And then attenuator 2's output goes to the amp, as you can see, into the amplifier input. And of course, the amplifier has an output. That amplifier output is the main out of the synth. Now, there's a 1/4-inch jack at the back of the synth that is the main out. But if you're going to plug this in and connect it to your rack equipment, that would be your main out there. I think I mentioned the inverter. It just flips the polarity of any signal upside down. Looking at the ADSR, we have a trigger in, and we have that's coming from gate. So if you look at the MIDI section in the lower right, you see the gate output. That's what triggers the ADSR. And then the ADSR has an output that we can plug to control the VCA or some other signal. On the AD envelope, we actually have a trigger input and an output as well. The trigger input gets its trigger from the ADSR. So if the gate goes into the trigger of the ADSR, that same gate will come into the trigger of the AD. Now, as I mentioned, the attack and decay sliders are controllable by other signals. So we can adjust the attack time and decay time, which is really kind of a neat effect when we're in the looping mode. And then, of course, the AD generator has its output. And that output goes to the amplitude modulation of the amp, as we saw earlier. All right, looking at VCO1 in the upper left, we have the keyboard, which is the signal from the MIDI section in the lower right, where it says keyboard. That keyboard pitch is going to go into the pitch jack. We have VCO2 going into the frequency modulation for VCO1. We have LFO2 controlling the ultra saw. And we have LFO1 controlling the pulse width modulation. We have the triangle wave as the source that we're running through the metalizer, and we're using velocity to control the metal mod. Now, everywhere where there's blue text over a jack, it's just telling you what's going into the jack if you don't plug anything in. But you can override any of those normal connections by plugging something else into those jacks. So you have complete flexibility. If you want the ADSR to control the amount of FM, easily done. Just take the ADSR out, plug it into the FM jack. Now in the bottom row, we see an input for sync. So this will allow the oscillator to sync to a second source. You could use VCO2 as that source, which is a pretty interesting effect. We have a second FM input called linear FM. We have a sawtooth wave output. We have a square wave or rectangular wave output. We have the triangle wave output, and we have the white noise output. In VCO2, we have something called pitch 1. So if the keyboard from the MIDI section is going to the pitch input of VCO1, then that also goes to VCO2. If you plug something else to control VCO1, that will to VCO2, and of course you can override that by plugging something into pitch 2. And then we have VCO2's output below that. Finally, in the upper right, we have the external in section. Now, if you want to go to the external input slider, you'll plug into external, the bottom of the 2 jacks, but we also have an input jack that can go directly to the master. So this patch bay, fairly compact, but really packs a lot of punch in terms of being able to manipulate stuff, both using the MiniBrute2S or MiniBrute2 by themselves. You can create different routings within the synth by hooking up the LFOs, the envelope generators, the inverter, the VCA, the attenuators, the sequencer. You can do all kinds of interesting modulations of your sounds, but used with additional equipment in the Eurorack realm, you open yourself up to other possibilities that can be really exciting and really interesting. So that is the tour of the sequencer section of the MiniBrute2S, and hopefully now that you've been through that, you'll have a fair idea of how to work the MiniBrute. Thanks for watching.